The best savings you can do is on unnecessary costs. Are you potentially losing money that could be saved in your data center? Today, we will answer this question for you and give you a solution that will help you address the continuous demand for optimization, energy efficiency, and data center sustainability. Hi, I'm Paige, the Global Marketing Manager of EPI. Welcome to the CRUR Workshop Part 1. First, let me thank you all for being here. I know your time is valuable and we appreciate your presence. If it's okay with you, I will take 2 minutes to introduce the speaker today, Edward Van Lint, Chairman and CEO of EPI Group of Companies. Edward has been in the mission-critical industry for 35 years. He grew EPI from a single office startup to a multinational company with global reach today, making a positive impact on thousands of data centers and the lives of the people who work in the industry. Edward is a dynamic leader who is highly respected and well-liked because of his extensive technical and operational knowledge and his direct, no-nonsense approach. Despite his busy CEO schedule, he takes time to talk with people who reach out to him. He sits on various data center standards committees and professional groups. There is no better person to talk about the topic today. I would urge you to take this opportunity to tap on his extensive knowledge and ask questions. Now, the moment you've been waiting for, I hand over the show to Edward.
Thank you very much, Paige, and welcome everybody to this workshop. I see on the list that people dialed in from various continents and time zones. So whatever time zone you're in, welcome to the presentation. So what we're going to do today is talk about the EPI CRUR workshop. That's basically the topic for today. And let me go into it in terms of the agenda. What we do, as usual, a very quick introduction to EPI, 1-2 slides just to introduce EPI for those who might not be familiar with us yet. We'll talk about some of the market challenges that data centers go through, and then we'll start talking about the new metric that we have developed. Do some summary, give you some resources where you can get more information, give you some tips on what we think are the next recommended steps for you to take advantage of this. And then obviously we open up the floor to all of you to provide answers to the questions through email page. So just a quick introduction. EPI originally out of the UK, started in 1987. So we are celebrating this year our 35th anniversary, and probably you've seen that we doing some nice promotions to celebrate this event. We moved the office from the UK to Singapore in 1999, and we grew the organization from a single office into 11 offices that we have now around the world, serving various time zones. And as you probably know, we have also a very large partner network. So we are basically seen in virtually every country around the world, at least where data centers are present. 3 services that we are focused on. We are very, very focused on the data center industry, and we do only a couple of things there. We do data center design validation. This is obviously for those who are embarking on a data center design and build project. So we validate the design drawings against the various standards that will be chosen by the customer. We also do auditing and certification of running data centers. We do that on the facilities portion, and we do that based on standards like the TA 942, EN 5600, ISO 22237, etc. And we also do the operational audits, so looking at governance, operations, maintenance, etc., etc. And we also do the training for data centers as well as IT. Most of you probably are familiar with EPI through this particular activity. So that was all about EPI very quickly. So let's have a look at the market challenges. I think everybody knows that there's a huge demand and drive for sustainability. You can't open up a magazine or a website where sustainability is on one of the top 3 parts of the agenda. So for data center operators and owners, both enterprise and commercial, there is a lot of pressure, both from customers who are demanding more and more, the management from the board that ask for more and more, but also regulatory. We see now in various countries things coming up in terms of regulations around sustainability. Some countries are driving data centers to a particular PUE level or even other metrics. And we all know that data centers, are not that easy always to change, right? We build them and they expect to live for 10, 15, 20 years, and any facility change could be quite an undertaking. And at the same time, of course, the customer said, despite all the changes and the drive for sustainability, still want the data center obviously to support their business critical applications, i.e. 100% availability is pretty much the norm that data centers are now looking for. So what have we done in terms of the sustainability drive? For years and years, we have been talking about it, and data centers have embarked on various projects to implement them. And most of the time, we started off with cooling. We all know that cooling typically eats up at least 30% of the overall power consumption in at least traditional data centers. And that was obviously one of the major things to tackle first. So a lot of improvements have been made. I think the good old hot aisle and cold aisle, which was a novelty in the early days. Now it's kind of the basic. Blanking panels, containment, either hot or cold aisle. And of course, also on the UPS front, there have been various technology updates to drive the efficiency there to a higher level. So this is what we have done already for many, many years. And we start seeing a little bit that we end up in the good old model where the changes that you do might not have a great impact anymore. Now, during this whole sustainability drive, there were also a variety of organizations that came up with metrics to start measuring data centers. For those of you a bit older already, you probably have heard of metrics like DCIN or DCIE and all those parts. But ultimately, the market has pretty much settled for PUE, the power utilization effectiveness, which is a very easy metric where we basically look at, say, the power consumption at the computer room floor, so to speak, the IT load, and we basically divide that by the total power coming into the data center building. So very simple, and because of its simplicity, it was widely adopted and it's still being used heavily, but also because of the simplicity, there were a lot of varieties in terms of how people approach the PUE measurement in the data center. And that has, created a lot of issues in terms of how we actually can compare facility to facility. So let's do a poll here, because it's always interesting to understand what customers are doing. So let me launch a poll here. And what we'd like to hear from you is what metrics are you actually actively using and measuring in your data center? So when I say active, that means, you're measuring it and reporting it maybe on a weekly or monthly basis, so to speak. And that is what you do. So it's not the one-off that you do at Christmas time, so to speak, but something that you're actively measuring on a so-called daily, weekly, monthly basis. So we'll give it a bit of time. We see that about 50% of the participants have already clicked. So if you can have a look at it, it would be great. Okay, you see the number still climbing, so I give it a bit more time. Climbing up. And there are multiple answers possible. So it is not just one. If you are using multiple metrics, you can click on multiple metrics in order to see. So, okay, the polls, okay, it starts slowing. Okay, let me close it here, I think. I think we have most of the votes still coming in. Okay, let's close it here. So these are the results. So here we can see, and I need to get my glasses on because I'm getting older. So PUE, as you can see, a lot of people are measuring it, and not a surprise, right? Because it was one of the first metrics that was pushed in the market to measure sustainability, or at least the facility effectiveness. Water, we all know, especially data centers where we are using a chilled water type kind of system that is there. And we also see a few people here using the CUE, the carbon usage effectiveness, and the the energy, or ERF is also used, the energy reuse effectiveness or factor. So as you can see here, PUE clearly is the winner, but it's good to see that also some people already start measuring on the carbon, etc. And I think this will be more and more important for the future. Thank you for your active participation. So let's have a look here. We all know that PUE is not a means to it all. It actually is very tough to say, if you have a good PUE, then you are an efficient data center. And here I'm just showing you a quick example. It's not elaborate, but here we can see a traditional data center where we have, for example, 10 servers running. We have connected it to a UPS. We have air conditioning installed. And because of this setup, we have an average here in this particular example of 1.4. Now let's say that we are going to be smart with our IT. We're going to virtualize our environment, which again, a lot of organizations have embarked on. So now we will have a much more effective use of our IT capability. And as a result, we need less servers. In this example, we ending up with 2 servers where we have virtualized everything. Still have the same old UPS running, and of course we have the air conditioner, which might not be so active anymore, and the UPS might not be so active anymore because we have less load. And what you can see now is actually by optimizing the IT, the PUE looks actually very bad. So this is one of the problems that we see in the market, where some people might say, hey, your PUE is really bad, you have not a very good data center, but in fact I rather have the one on the right than on the left in this sense, of course, because overall the right one is much more effective use of the IT, etc. So this is just one of the problems with PUE, and I'm sure with those of you who've dealt with it, and out of the poll we can see a lot of you, that there are many other issues there. So the question is really, with PUE, is that the right thing? Do we need to have more like PUE and WE and CUE, etc.? So what can we do actually to get biggest gain? What do we need to measure? But also we need to look at, say, what is actually the biggest destroyer of what we call the return on investment, especially in a commercial data center. Everything that you spend on the facility as well as the energy usage, of course, has to be recuperated from obviously the rental and the services that you provide to your customer. And let's face it, the compute room is really where most of the savings can be made. As I showed you just now with the IT environment, you can make substantial savings, although your PUE might look very bad. But in the end of the day, whatever you do on the compute room floor will, of course, have a multiple impact on what is happening on the building, right? With the PUE, if you have a PUE of 2 and you save 1 kilowatt on the floor, then theoretically you would save 2 kilowatt at the utility site, and that obviously is what we would like to have. But the problem is in the industry that the compute room has typically been, heavily over-designed and is typically therefore also underutilized. A lot of the designers want to play safe, right? We don't want to be called by the customer tomorrow and say, well, I have shortage of power or cooling. So that is why a lot of designers go by the, what I say, the principle of better 100 kilowatt too much than 1 kilowatt too little. If I have over-designed the facility, the customer is not going to call me 2 years down the road or 3 years down the road and shout at me to say, well, you have to over-design it, right? But if I design 1 kilowatt too short and therefore the business will come to a halt, then of course the phone will ring. The other problem is, of course, not all to blame to the designers. We typically don't know what the business is going to do. Ask yourself, do you know what your business is going to do in 5, 10 or 20 years time? You probably don't. Who would? Changes in technology, we see that now also heavily happening. So it's very hard to design the data center for the future. We try to design it flexible so that we can make changes along the way, but it is always there. So this is a big problem. Over-designing, underutilization, and in the end of the day, a lot of times people even don't realize it anymore because once it's built, nobody looks back because we're moving on to the next project. So let's have a look at another poll here. Talking about over-designing. You all have a UPS, I'm sure, and typically we have 2 UPSs, maybe, right, an A and a B feed. So let's do a poll here again, where we ask you, what is your current UPS load? Now, let's assume N. Yeah, so if you have, for example, 2 UPSs, because you have redundancy, let's say if you switch one leg off, what would be the load then on the surviving leg? So we're really going into the end stage. So again, let me grab my glasses here to have a quick look at the poll. Okay, the numbers are still climbing up and coming in. So here we'll see, okay, we have about 60% of the participants coming in. Okay, climbing up to 70%. I'm very happy to see that a lot of you are very active today, which is great. I'm up 75%. Excellent. Okay. Okay, give us a few more seconds and then we'll close the poll. Okay, let's close the poll now. Going once, going twice. And here I'll share the results. And as you can see, a lot of data centers running only, basically 40 to 60%. That is the majority. If I look at this statistics here, there are some very well utilized data centers with up to 80% load, 60 to 80, also not too bad, right? But you can see that the majority, if I look at it quickly, more than 75% of the data centers are running, at 40, 60% or even less. So again, this substantiates the idea that unfortunately there is a lot of wastage in terms not only of design and build, right? Because obviously if I design 100 kilowatts and I only use 50, then theoretically I've lost a lot of money. But it also is creating energy inefficiencies on the data center itself. Okay. Now, of course, some of you might argue, say, well, we've planned for the future, right? We just started the data center, so currently we only have 20% load, but it's estimated to grow to a higher level. Of course, I assume that not all data centers that you are representing here are in the final stage of deployment, so to speak. There might be growth there. Excellent, fantastic again for the great poll results. So yeah, the cost of over-designing and underutilization, as I said, it has a huge impact on the ROI, especially if you are a data center designer or the commercial data center and you have over-designed it, then it's very hard to get your money back. It also has the environmental impact, not only because you have built too much, but also because of the inefficiencies, and all this underutilization create a lot of operational expenses. I think those of you who are in facility maintenance know that underutilized equipment typically isn't too happy. Generators, chillers, etc., underutilized are very inefficient and typically require even more maintenance as well. So this is one of the problems. Now the other problem is, and I didn't want to create another poll so quickly, but ask yourself the question, right? Do you typically take the lessons learned from your current environments or your the previous environments and use them in the future? So if you know that you have 2 or 3 data centers that you had built and they were all over-designed and underutilized, did you scale back? Or were you nervous and say, you know what, let's just do the same thing over and over again because I worry about this 1 kilowatt too little, so to speak. So what we have done, we said, you know what, we need to do something about this. We need to help data centers to have better insight. And that is where we have developed what we call the CRUR, the Computer Room Utilization Metric. So CRUR, the Computer Room Utilization Ratio, is really aimed at looking at the ICT equipment, how well it's deployed. We're looking at the computer room setup itself, and we're looking also at the direct supporting facility. So that's what we're all looking at. Now, be aware that CRUR is not a replacement of PUE. In fact, it can work very nicely together. And what you will see is that if you implement this and you are working towards increasing the CRUR outcome, you will see that your PUE automatically will start dropping. And that is obviously a fantastic result. And likely, if your CRUR is getting worse because of whatever happens in your data center, then you will see that your PUE will go up, and that obviously is also not desirable. So how do these things work together? Well, here a simple picture. As you know, PUE is always measuring the IT load, and it compares that to whatever power goes into the building. A very, very simplistic representation. So we actually only looking at the cooling efficiency and the powertrain, the UPSs, the PDUs, transformers, and all that part. CRUR is basically looking at the computer room, as well as the mechanical and the electrical systems, up to the UPS. Or up and to including the UPS, I should say. So we are not looking at the entrance of the building, so to speak. We're not looking upstairs about the chiller itself. That is something that is already nicely covered by PUE, and that's why I said they can live nicely together. Now, be aware, in the CRUR, we have basically defined 3 metrics, and they are denoted by a little letter, as you can see in subscript, CRUR-F, which is for facility, where we basically look at the facility equipment, the computer room utilization, etc. Then we have the CRUR-IT, which is related to IT, and then we have the ITF, which is basically covering all of it. Okay, so this is what we have. Now, CRUR is basically a metric, yeah, where you have a number divided by another number. So it will always be similar to like what is POE, a number. In this case, 1 would be perfect. Anything below is less perfect. Yeah, so CRUR is always a 0 point something, and the closer to 1, the better it is. Now, one of the important things to understand is that in the CRUR metric, and I'm going to show you later more details about it, we do not use weight factors. So, for example, we are not going to argue about that, for example, a more optimization of your rack space is more important than, say, for example, optimization of your cooling or optimization of your UPS infrastructure. Okay, why did we do that? Well, very simple, because we know that once you start applying weight factors, everybody will argue about what is more important, because that varies per data center and obviously operations. And if you allow the data center owners themselves to set weight factors, then of course we know that the tuning will be done to make us, look as best as we can. So we said no weight factors, everything is declared as 1. So let's have a look at the details. CRUR facility, F. What do we have in this particular metric? We're looking at stranded power capacity. We're looking at the power capacity utilization. We're looking at the mechanical versus power utilization ratio. We're looking at the mechanical capacity ratio. And we also look at the rack optimization. Yeah. And as you can see here, we take each of those parameters, we divide it by 5, i.e. there is no weight factor, and that will give you the overall CRUR facility. And again, closer to 1, the better it is. So have a quick look at, say, the various options. We will organize another workshop in the future where we'll go into much more detail to help you how to calculate, etc. So this is just an overview. Stranded capacity. Yeah, stranded capacity, a very simple definition, is basically capacity that you're not going to use. So in the picture here on the left, we see we have 2 UPSs, obviously for redundancy, but we know we will never achieve full 100% on both units. We do 50% load maximum, the theoretical maximum. So theoretically, we have a stranded capacity of 200 kilowatt here. We bought it, we're never going to use it, hopefully, only when there is panic mode and the other UPS, goes for maintenance or has a problem. Obviously, when we do different design methodologies, so on the right, you see, for example, a system, what we call a catcher system, we can have higher utilization, therefore less stranded capacity. And as you can see, the SPCR rating, the stranded power capacity ratio, will become closer to 1. That is what we use for optimization. So obviously, this is something that you can't do in your existing data center, right? You can't do it. Well, you could, but it's very troublesome to do it. But for new data centers, you could say, let's push the SPCR to a higher level by using this type of technology and setup. We're also looking at power capacity utilization ratio. Well, that is very simple, right? Because in the end of the day, we're looking at how much IT load we expect in the computer room, and that's how we size the power. Obviously, when we have growth over year, one could look at methodologies like scalable UPS systems, etc. Yeah. So again, the closer to 1, the better it is. So theoretically, if I have 100 kilowatt of UPS and I have 100 kilowatt of IT load, my PCUR rating will be 1. Of course, as we said, we always have N split over 2 typically, but for this particular metric, we're purely looking at N capacity. Yeah. Another important part, the mechanical power versus the actual electrical power. You all know, if you have attended a course from EPI, or if you have, done some research, you know that the good old rule that we learned in school, energy cannot be created, energy cannot be, lost, right? It's always transformed. So theoretically, if we have 1 kilowatt of electrical energy going to the computer room, we only need 1 kilowatt of sensible cooling capacity to be applied, and then everything will run perfectly. Now, we also know that we might have some losses because of, air that is mixing, non-optimized airflow under the floor, in the room, whatever it is. And therefore, what we see that some of the designers over-design the air conditioning capacity, because we worry that if we do it too tight, let's say we have a one-to-one relationship, then we might get all kind of practical issues. Of course, that could happen depending on the design, but that will mean overinvestment again, etc. So the closer you can bring those metrics together, right, the better it is. So this is one of the things that we measure. We're looking at how much is your mechanical cooling capacity in sensible heat and how much is it in electrical. And obviously we try to measure those. We also need to look at, say, the mechanical capacity utilization ratio. So if you have 100 kilowatt of mechanical equipment installed, ideally you would like to have close to 100 kilowatt of heat load. Now, sometimes we have less, of course. Sometimes we have too much air conditioning capacity, especially when you're ramping up your computer room and you're still wheeling in IT equipment. But then again, there could be different scenarios that you could apply. In order to make this ratio better, there might be scenarios where you turn off equipment, or in some cases, if you turn off is not desirable, you might have lower fan speed rotations, etc., etc. So what we do here in this, we're looking at the IT load, we're looking at the mechanical capacity that you have installed in kilowatt, and then we compare those. And what we normally do, of course, we're looking at N again, so we're taking out the redundant components unless they are actively participating in cooling the room. And then the last metric in the facility is the rack utilization ratio, where we are looking at, say, how much use space do we have available, and then how much is actually being occupied. Yeah, obviously this only works for rack-based type of data centers, which are most data centers, although there are still some enterprise data centers that look like a museum, where we have other equipment, etc., etc. But we are calculating this one purely on available use space. It's independent of technology and how you set it up. Sometimes we get the question, yeah, but we have top of the row or end of the row type, or top of the rack or end of the row type of network architecture. Does that have an impact? In fact, it doesn't. Yeah, we all look at capacity. So those are the metrics that we are looking at. And again, we try to optimize them by making changes in the data center. Either if we can do it in existing, or at least for the future, we can also look at optimization for designs. The other metric is the IT metric. So what are we measuring there? Again, we're looking at 5 important components: the data storage utilization, computer power utilization, memory, network port usage. So we're not talking about utilization here, we're talking about port usage, and network bandwidth utilization. And as you can see, we're not doing any weight factors here. It's again divided by 5. And again, close to 1 is what we're looking at. So data storage. Now, the problem with data storage is far more dynamic than what we have, for example, in facility power, right? Power might fluctuate a little bit due to demand, but with storage can often go up and down. Now, what we would like to do as a data center, we don't want to buy too much in advance. Why? Because in historical reasons, and again, I know that some of the seasonality might have differences. We know that there now is a shortage of silicon in the market, therefore prices tend to go up. But in the traditional market, storage prices are always dropping over time. So if I buy 10 gig today, but I only use 1 gig, I'm basically wasting 9 gig, because next year, when I start maybe hitting 5 or 6 gig, if I would have bought the 10 gig then, or added another 5 gig, I could save myself a lot of money. Now, we know that data storage is not that simple, right? It's not just about hard disks or SSDs, etc. Very often we do virtualization of storage. Not a problem, because our metric has catered for those environments as well. So we're looking at what we call storage pools, which are typically related to applications. And then we start measuring again, what has been allocated versus what has been actively being used. Now, other option, or the other item, computer power utilization. For the oldies, we know that in the old days when we looked at IT hardware, and actually, in fact, we still see it a lot in tender documents, people are looking at the performance of the equipment, typically in MIPS, flops, or whatever metric they have. Now, that makes it very, very hard for calculation. So what we have decided to say, it's very simple, actually. A CPU, when it runs at 100%, that's the theoretical maximum. Anything less than that, you could argue, is maybe less optimized in terms of utilization. Now, we know that there are sometimes different arguments, different processes run at a better energy efficiency level when it's even a throttle down a little bit. So 100% utilization might not always be the perfect set point for a CPU, but we had to take a benchmark, of course. So what we say here, we take 100% of CPU as the benchmark. Anything less than that could potentially be a wastage of your consumption. Now, the example that I gave you, right, where we have 10 servers, typically running probably at very, very low CPU load. If I move that into a virtualized environment running at a higher CPU utilization, then this metric obviously would look better. We also know that CPU utilization is extremely, vulnerable to application usage, etc. Right? Look at your own PC. If you open up the good old workload manager, you can see that the CPU utilization is jumping up and down. So for this, obviously, you cannot say measured at one day at one particular timestamp, because that would give a very distorted factor, right? So this measurement has to be done over 7 consecutive days to get a proper idea of the CRUR ratio for the IT. Same as with memory. Memory is also very dynamic. It also goes up and down. What we do here again, similar with storage, we're looking at memory pools, which are typically tied to applications, right? So they could be tied to what we call a CPU pool, because typically applications are bonded to a couple of CPUs. So we do the same thing here again. We look at memory allocation that you have done, either static or virtual. Both is supported by this metric. And then again, we're looking at the utilization. Again, 7 days, of course. Network port usage. Now, this is quite important. We got quite a lot of customers actually asking questions, say, why would you bother? But the fact is that every network port is using power, especially when they are equipped for PoE, where a lot of them are, right? So if you have too many ports, it is a wastage of money, obviously, and it's going to be a waste of power. Not every data center has the discipline to throttle back the line forwarding rate, or turning ports off that are not being used, etc. So this could potentially has a big impact. So this is one of the metrics. Again, we look at what is available, what is being used. And we're looking at the network bandwidth utilization, and we measure this, again, per computer room. So we're not measuring at the pipe that comes into the building, because very often that pipe is split also on other users. There could be office users, etc., etc. So normally what we measure here is we're looking at the MBA, MDF, depending on how you define the name. So what goes in as a pipe into your computer room, we measure there, and then look at the utilization. And again, similar to all the other IT ratios, they are very dynamic, and therefore we say you need to measure it over 7 consecutive, 7 days in a row. And if you want to do both, well, very simple. You take your CRUR facility, you add the CRUR IT, and again, we do a simple divided by 2, and that would give you the overall rating. Okay. So let's have a look at a poll again. I'm going to bring up the third poll. In terms of the CRUR, you have now a little bit of a flavor. We know that it's not in great detail. We'll organize other workshops, as I mentioned. Do you think that this metric could actually help you, for your data center environment? Is it going to help you a lot? Do you think it's maybe, not helpful? Do you think that you have everything already under control? Do you think you're a bit confused? Still need to read up a little bit. So let's have a look. No, we have it all under control. Maybe need to look at more details. Yes, it will be helpful. And the other one, not sure, bit confused. So let's have a look at the results that are coming in. Again, you guys and ladies are very active today, 65% and climbing. Really happy that everybody is very active in this particular session. That is great. All right, we start hitting the 70%. So we'll start ending the poll in the next 5 or 10 seconds. Let's have a closure on that one. And I'm going to share you the results. So these are the results. So no, there's some that say, everything is perfectly under control. Fantastic. Very, very good. Maybe yeah, I think, and I'm not surprised, it's very early, of course, we just do an introduction. So in that sense, I can imagine that you still need to read more about it. Yes, it will be helpful. A lot percentage actually as well, 50%. Not sure, very confused. Probably you will have, when you read through the document, get a bit of a better understanding. And of course, for the next sessions that we're going to organize, we will provide you much more details. So hopefully then I will start to clear up some of the questions and confusion that you might have. And of course, take the opportunity today to ask questions on the Q&A box. Okay, let's go further with the presentation. So as a summary, we say that CRUR is really addressing, the biggest problem in data centers. It's really oversizing, underutilization. You can have the best UPS in the world, you can have the most optimized chiller in the world, but if your data center computer room has been oversized and underutilized, it's very, very nasty still. So the other good thing about CRUR, as we said, you can apply it to any type of data center. It doesn't matter whether it's a commercial or enterprise data center, whether it's cloud or whether it's just a standard, data center, it can be applied. For data center operator owners, actually, I must say, we had some discussion with some of the operator owners and they actually like it a lot. You know why? In some of the countries, the data centers, commercial data centers are now, potentially being penalized for having a not optimized PUE. Now here comes the problem. I have my customer coming in, promise me to take up 20 racks at full load, 6 kilowatt, and they come in and they only fill up 5 racks and running at 1 kilowatt. So now I have a heavy underutilized area. That means that my PUE will be, penalized. Yeah, the PUE will go bad. And now as a data center operator owner, I might get penalized from the government because my PUE is not meeting what is the regulation or what has been set as the benchmark. So what operators can do is actually apply the CRUR also to their customers and say, what, you need to make sure you hit a certain level because otherwise we get penalized. And hey, if we have to be penalized, then by right, maybe you should be as well. So there's quite an interesting observation from some of the data centers to say we can really help our data center to be more balanced and to make customers understand don't oversubscribe because it basically is bad for the environment as well as for your wallet. Okay, so in that sense, the other good news about CRUR, you can apply to existing data center and then maybe use that lesson learned for your future data center to be a little bit more careful with all the oversizing that typically happens. So for those of you who would like to know more about CRUR, you can go to the website here, as it says, www.epi-ap.com/CRUR. There is a download, it's a free download. The document is available with all the details in greater discussion, what each metric actually means and how it should be measured, etc. So take advantage of that to read through it a little bit more and find out whether you could apply to your data center environment. Okay, so recommended next steps. Yeah, first of all, download that document. It's free. Yeah, read it on the Sunday afternoon, so to speak, to get a better understanding. We have 2 other workshops lined up. One will be specifically around the CRUR facility. So we'll provide you there with more insight in how you can actually measure it in your own data center, how to calculate it. We'll give you some examples so that you can use that lesson learned and apply it to your own data center environment. If you need help, if you have questions, say, I have this particular setup, what is included, what is excluded, by all means, reach out to us and we can help you. And we will also have a workshop dedicated to the CRUR for IT. Okay. Of course, you can already start now, review your monitoring systems and see whether you can start including some of the CRUR metrics. I can tell you that we are at the moment already in discussions with some of those DCIM vendors, etc., to make CRUR a standard metric in their environment. So you can have it on your good old display on a daily basis, so to speak. So start monitoring it and from there create improvement plans either for your existing data center or for your future data center. And with that, we have come to the end. So that is great because we have about 15 minutes plus for the Q&A. So what I will do, I will hand it over to Paige to arrange all the logistics on that part.
Thank you, Howard. We already have quite a number of questions, so I will just dive right in. First question is, what is the relationship between cooling, BTU, and volume of the DC room?
Right. Okay. Well, now BTU, or it could be also the cooling capacity could be defined in many metrics. BTU, British thermal units, or kilowatt, etc. Normally, the room, theoretically doesn't have a lot to deal with it. It has to be related to the kilowatt heat load that is generated by whatever is in the room. There are some other things that we look at normally. Is there any heat gain in terms of, say, windows or humans walking around or other heat sources? But theoretically, you can have a small room with 100 kilowatt. You can have a small room with 1 kilowatt. So the volume of the room is not directly related so much with the cooling capacity. Of course, you cannot have a 1 kilowatt air conditioner in a 20,000 square feet computer room. That will not work either, even if you have only one header. Every air conditioner has a certain throw and certain reach, so to speak. So there is a relationship, but it is not a direct relationship so much as the cooling capacity really related to kilowatt of the IT load.
Okay, next question, Everett. Can we do away with PUE and just use CRUR for the future?
I would say no, for two reasons. First of all, as I discussed, the PUE is really looking at the effectiveness and efficiency of the facility equipment, things like the chilling, the chillers, the infrastructure around the UPS efficiency itself. So in the CRUR, we are not measuring for example, the efficiency of the UPS, right? We measure how much load is on the UPS, and we compare that with the other metrics, and we're looking at, say, the stranded capacity, but we're not measuring the effectiveness and efficiency of chillers and things. So I would always use it hand in hand, and in some cases, data center operator owners are forced to report on PUE either to regulatory bodies or to their customers. So definitely don't do away with PUE, still a useful metric, but use it side by side with CRUR.
Thanks, Edward. This is kind of a related question. I think you kind of answered it. What is the end game with CRUR? Is API trying to get CRUR to replace PUE or coexist with PUE?
Coexist. Yeah, clearly coexist, because PUE is really, as I said, addressing the facility efficiency portion, so to speak. PUE doesn't address anything about room setup and all these parts. So that is what the CRUR is good at. So definitely a side-by-side, unit, not a replacement.
Good. Next question. How can we know that CRUR number indicated by a data center is true?
Well, yeah, that's always an interesting one, because that kind of like depends on who does it, right? So for the CRUR, of course you can do it yourself, right? So you could do your own measurements and report it. As we indicated, do a proper reporting. So if you are measuring your CRUR for facility only, which you can do, you don't have to do both, then when you write your CRUR number, write it as CRUR, with subscript F, so that people know, oh, this is purely for facility. We also, as EPI, offer a service to do audits. In that sense, we can do the CRUR calculations and review for you, and then we will, issue a certificate. So in that sense, then you could say it's done by a third party. We are looking at other organizations as well that will be authorized to do the CRUR review and audits.
Very good. Next question. How efficient is the cold out containment, and how many % savings can be achieved? Not so much a direct question regarding the CRUR, a general question about cold out containment. It is efficient. It's very difficult to say, it's going to save you 10% or 20% or 30%. That all depends on your overall setup. But cold out containment, the good thing is it makes sure that the cold air goes where it's supposed to be, which is the front of the rack, right? It prevents the mixing, as long as you have also blanking panels within your rack. So it can achieve good savings. But
You cannot say it always, gives you 10 or 20 or 30% savings. That, is very much dependent on other factors. But definitely is something that you should be doing if you can, because it does really help with energy savings.
Okay, we have a lot of questions coming in, but no worries, we're going through them. Well, the next one is, will there be any ISO or TIA standard for CRUR in the future?
Not at this moment, not in the works, but depending on demand, because for it to become an ISO standard, there need to be market demand. So as we see that climbing up, if we see that more and more people are using it, then this could be pushed towards the ISO bodies as a new metric. So we're monitoring obviously that closely, and when the time is right, then we will propose it to ISO to be included. For TAA, not yet. TAA is more of a design standard, not so much about energy efficiency yet, but that can be seen if TAA goes into that direction.
Thanks, Edward. Another question is, what do you recommend for starting with CRUR? Is it doing the facilities CRUR first or the IT CRUR?
I would say start with facility. And the reason is that it's the most easiest one to tackle, because it's very easy to get the numbers in terms of power consumption on the UPSs and the IT load and the CREC, the air conditioning capacity. So it's a relatively easier to do. For the IT, it's more complex, and it's not something that you can easily do without installing or deploying your existing network monitoring or application monitoring and system monitoring tools, because you can obviously not go into in a room with 10,000 servers and take out your piece of paper and write down the loading, because that is impossible. So I would say start with the facility one. When that is under control, then start looking at the IT.
Thank you, Edward. Another question is, doesn't the life cycles of the ICT and facility infra also impact the ratio and ROI?
Yeah, absolutely. Absolutely. It does. But obviously the CRUR is not addressing that particular portion. We try to make sure that the CRUR is really at optimizing deployment. So yes, of course, if you throw your service away every year because of whatever reason, then theoretically you're throwing more carbon footprint in the world, and you will be considered to be, less optimized. But that is out of the scope. So we're not talking about asset management within the CRUR. We're purely looking at, say, operational efficiency on a daily basis, pretty much.
Okay. Next question is, what is the expected impact of this CRUR matrix if we implement it on a modern modular data center?
Well, if you have designed your modular data center right, and again, the whole idea around modular data centers is that you can scale as demands grow. Your CRUR in general, definitely not always, but in general, would be better than a traditional data center where you have, for example, a floor of 10,000, 20,000 square feet, and you start, properly or populating that over months or years to come. The advantage, of course, is with a modular design that you're pretty much, up to the, the full loading theoretically, in a relatively short timeline. That's it. So CRUR on a modular data center that is well designed definitely will be more closer to one than a traditional legacy data center design.
There's a question where this person asks, can you explain more about what is meant by consider growth plan?
Okay, that is for the PCUR, the power capacity utilization ratio. With that, what we mean is that if your data center is designed and you start building it and you turn it on, you will not have, your optimized maximum capacity load. Right, you could start with maybe 20 racks, and your data center could grow to 100 racks, for example. So that's what we need with PCUR. So PCUR could look, for example, not so great as an individual metric, because you are in the early stages of your deployment. But that is not a problem, right? We don't say that your PCUR has to be 0.6 or 0.7. We just say measure it and keep an eye on it so that you can improve it. Also, be aware that the ratios that we indicated, what is another good side effect of it? You can use it in your capacity planning, right? Because if I know that my PCUR rating is say 0.4, I know that I can theoretically still grow to 1. So that is where the CRUR can also very quickly give this dashboard overview, so to speak, in terms of where am I in my capacity planning, yeah, on an overall basis. So that's another good use for the CRUR metric.
Okay. Thanks, Edward. Next question is, may I know how to balance the PUE and I think safety factor of the data center, such as maximize the loading of the UPS. However, it might lower the safety factor of the data center.
Right. Yeah. Well, okay. Yes and no. Obviously, in a traditional legacy type of setup, we have always the A and the B feed typically, and we make sure that the A and the B feed are not more than typically 40 to 45% loaded, to make sure that if there is a failure or maintenance required on one of the legs, that the other one takes over and not hit more than 90%, which is what most people consider to be, the ultimate maximum that we would like to have on that type of environments. So yes, going towards the maximum will create, better efficiencies, etc. But if not managed well, yeah, it could create also a higher risk factor, especially with dynamic loadings, etc. So we try to balance it. And again, that depends very much on the data center. If you have a data center that is relatively stable in terms of loading factors, then you can deal with it easier than if you have, for example, a data center that goes through very high fluctuations of, for example, storage access and CPU utilization, because that can bump up the power consumption. So that's why you see, for example, in some of the data centers at night, the power consumption goes up. And people wonder why it is. Well, it could be because your backups are running, right? And therefore there's a high utilization rate on all your storage access, etc. So, but yeah, we try to optimize the PUE, versus the risk factor, which of course depends on the risk appetite and the dynamics of each data center.
Thank you, Edward. There's quite a number of questions around DSIM, so I'll try to consolidate it. Which DSIM tool, in your opinion, is the closest to full support and CRUR? And do you reckon that CRUR data will be included in most market DSIM today? Okay, well, in terms of, we are, as I said, in discussion with a few of the tool manufacturers, tool suppliers, I should say, manufacturing sounds like a factory. So the tool developers, there are a few of them that have already said that they should be able to do it, but they are now looking at, practical scenarios to see whether they can actually really do it. As mentioned, the CRUR IT is typically not covered because that's more towards the system management tools, right? The BMC patrols and all the other fancy tools that are available. But for the DSIM, most of the common, I would say, top 5 brands, they should be able to do most of the CRUR, although some of the stuff might not be so easy to do, like rack utilization. That all depends on, for example, whether the customer is really maintaining the tool properly. Power, cooling, that is fairly simple because most data centers are measuring it now as part of the PUE overall measurements strategy anyway. But if you look at, say, utilization of rack space, that very much depends on how people do asset management and how well they maintain it, because some are very active when they started, and then after a while there are too many changes and they don't update the tool anymore, and then it obviously becomes less effective. Thanks, Edward. Taking a question out of Q&A now, seems like this CRUR is impacted by the TIA rating and redundancy method used N+N versus N+N1. Okay, only partially, to be honest, because the only metric that is really impacted by your redundancy design, that will be the stranded capacity. Right, so if you go for a traditional A and B, your stranded capacity factor is of course very high because you have basically designed 2 data centers in one, right? 100 kilowatt on the floor, I have to have 2 times 100 kilowatt UPS, for example. But with a newer design, like the catcher type of system, etc., you can dramatically bring that number down.
all the other parts, in terms of, for example, air conditioning redundancy in the computer room itself, as explained, if they are active recountant with it, if you have rotating schedules, then they will not be counted towards the capacity, and therefore, yeah, it will give you a different number, so to speak. So the biggest impact on the design of the UPS A and B scenario. For the rest, you don't have to worry. It does not have a great impact.
Very good. We still have a lot of questions, but we have 3 minutes left. What do you think, Edward? Do you want to continue, or shall we take it offline?
No, let's take 1 or 2 more, and then the ones that we unfortunately can't answer, we can get back to them on the email maybe.
Okay. Let me pick one. What is the allowable margin of error in computing the CRUR? What are the red flags or factors to be considered?
Right. Well, in terms of, we haven't set a particular deviation margin, so because it's very hard to establish those, right? And as you know, for example, when we're talking about, say, the computer load, the IT load, yes, that might vary in a data center a little bit up and down. Therefore, theoretically, your calculation might be off. But we look at the CRUR similar as PUE. You're not doing it once a year. You will do it probably on an ongoing basis. So you might see over the weeks, over the years, that your CRUR is slightly, floating around a little bit depending on IT load and all these parts. But there is no fixed margin. We're not saying, plus or minus 5% or 10% is allowed. That is not applicable in this case.
Okay. Next question. If my data center is currently underutilized at 40%, what are the actions I need to take? Okay.
Well, it depends on where the underutilization is. If, for example, all your racks are full, but your IT load is just very low, yeah, there's not much that you can do. You can optimize racks maybe. You can looking at, say, can I deploy less cooling by either tuning down the rotations of the fan, if that is possible on the equipment, increasing temperature on the air canisters in terms of the return water and all that. So there are a few things that you can do to optimize an existing data center. You cannot always, make a huge change, right? You cannot say I turn off all the air conditioners except one, because then you might get pressure issues in the floor or those kind of parts. So it is really individually that we need to look at, say, where can you make the biggest savings? Is it on the power side? Is it on the cooling side? Is it on the IT side, where you could optimize racks better to get a high utilization?
Very good. We're at 5 o'clock.
Okay.
So yes, thank you very much, everyone. It's really fantastic seeing so many questions coming in. We don't have time to take all, as Edward has said. We will get back to you offline for those questions that we didn't manage to answer. And once again, I thank you all for joining us. I hope you take away the information that Edward has shared today. Use it, you might discover some interesting surprises. I hope none alarming ones, but yeah, do remember we are here for you. So if you need any assistance, just reach out to us. Edward?
Yeah, no, great.
From you.
Thanks so much again. And yeah, we hope to see you again also in the next upcoming workshops, where we dive into more details on the CRUR and how you could measure it yourself and some of the examples there. So we hope that you will join us again then to take some of the lessons learned and hopefully can apply it in your data center.